GCSE Physics boosters, Electromagnetism. Now, 1820, a Danish scientist called Ørsted, Hans Christian Ørsted, showed that electrical currents produce magnetic fields. We know that permanent magnets produce magnetic fields, while something else does as well, and that is a current. A current produces a magnetic field. Now, the way that he showed it is very similar to the way that you might investigate it, which is with a compass. Now, on this circuit diagram, it's just basically a power supply and a switch. And at the moment there's no current, so the compass is pointing north. Now, when there is a current flowing, notice that the compass is deflected. And it depends whether the compass is above or below the wire. When it's above the wire, it points a certain way. When it's below the wire, it points the opposite way. Okay, so this is how you could show the magnetic effect of a current by using a compass. So what is the shape of the magnetic field? I won't say what does the magnetic field look like because it's invisible, but the shape of the field, it is circular. It's circles, concentric circles around the wire. If you increase the current, then the field gets stronger. And then pretty obviously, as you move further from the wire, the field would get weaker. So we have these circles of magnetic flux going around the wire. You might have to sketch this diagram, okay? Now, a single straight wire produces a magnetic field, but it's not very strong, so it's not much use. Now, one way that you can get a much stronger field is if you get a tube, like a cardboard tube, and you wrap the wire around the tube to form a thing called a solenoid. So if you have lots of turns of wire, yeah, and then each turn produces a magnetic field, and then they all add together, and that is called a solenoid, and that produces a much stronger magnetic field. The field due to a solenoid, now outside the solenoid, it's very, very similar to a bar magnet. In the last video, we talked about bar magnets, and outside the solenoid, it's the same shape as a bar magnet. Inside the solenoid, in the middle of the solenoid, we have a strong and uniform field. And that's going to be very useful later on for some of the electromagnetic machines that you can make. Okay, so in the middle of the solenoid, there's a strong uniform field. How can you increase the strength of the field? Well, you can increase the current. You can have more turns. Don't say more coils, there's only one coil, but if you have more turns on the coil, and then you can have a core made of iron. If you have an iron core, then the magnetic field is much, much stronger, like hundreds of times stronger. And if you put an iron core in a solenoid, then we can start calling it an electromagnet. Okay, a solenoid with an iron core is called an electromagnet. Here's an electromagnet in a scrapyard picking up lots of iron and steel. Okay, they can pick up very heavy loads. A little question for you. What are the advantages of electromagnets over permanent magnets? Have a little think, and the answer is you can make them very, very strong. If you had permanent magnets doing this job, they would be incredibly heavy. And secondly, the fact that you can turn it on and off. So, you know, you flick a switch and then all of this iron falls to the ground or wherever you want it to go. So you can turn them on and off.